Hello everyone. I hope you all are having a great time and you had celebrated Diwali with a lot of fun and with your family. Now, let's jump on to today's problem, which is reversing a linked list. It is an easy rated problem on Leetcode, but as you can see, it has been asked by a lot of companies, and in this series, we will be continuing all the product based companies' favorite questions over there. Now let's jump onto the problem. So as we can see, we are given a linked list and we have to reverse it. Now, uh, if you are not aware of what is a linked list, so a linked list is a data structure in which each node is having a reference for its next node. So uh, in this case, we just have to reverse the linked list. So I will just take you to the jam. So let's say we are having a linked list as 1, 2, 3, and 4. So our aim is to make the linked list as 4, which is pointing to 3, which would be pointing to 2, and which would be pointing to 1 in this case. So the most naive approach which can come to anyone's mind is to use a stack. Why stack? Because a stack is having a property of reversing the elements. Like if we are putting some elements over here, like let's say I am putting 1, then I am putting 2, then I am putting 3. So we would be getting 3 out at first, and then 2, and then 1. So the stack is basically FIFO. So this can help us in reversing this linked list. So let's see how can we implement this using stack. So for implementing this, we can simply declare a stack of type list node, and since we are given uh, the reference of the list node, we can store it in some variable as temp, and now we can simply store all the nodes in this stack only. That is while temp dot next is not equal to null, we can simply push the node to the stack, and we can simply do a next node. This is similar to what we can do in I++ or J++ in normal loops. This is similar to that only. Once we have got all the nodes in this stack, then the the topmost node which has been pushed the last, I mean, let's take this example. um, Over here, like we can see, the fourth node would be pushed last in this case. So let's say 4. So this the temp would be pointing to this node only. So this would be our new head. So in this case, we can simply say that head equal to temp, and after that we can again run a loop that while stack is not empty, we can simply make temp dot next as stack dot remove, or and temp equal to temp dot next. I hope that actually makes sense, and at last we can return head. Let's try to run this up. Okay, it says it founds a cycle. uh, can do one thing here. uh, yes, so the issue was that we haven't pointed that thing. So what was happening actually, let me just tell you that we have reversed it completely, but the problem was that one was the one was pointing to 2 only in this case. Let's say it was the last node in the stack, so it was pointing to 2 only. That's why it said that it is getting cyclic. So that's why we pointed it to null. And yeah, if we try to submit this, okay, so I think that's a edge case probably, that if or head dot next equal to null, then we can simply return null, because we are having empty input over here. So first I will try to run this for this test case only. Works, and let's try to submit this. Okay, not null, it was my bad. Return time. Yeah, accepted. But what's the problem with this approach? That we are using a space over here, and also we are using two loops. So the two loops are not a problem actually, because the time complexity would be big of 2n, which is equivalent to big of n only. But this space is making a issue. Alternative to this, we can also use a recursive approach, but that would also be taking a stack space of big of n internally. So now let's try to understand the optimal approach, that how can we just do this without using any extra space as well. So I will just reset it first, and let's try to visualize it. Let's say we are having some linked list. Let's say 1, then 2, 3, and 4. So now tell me one thing. We need to reverse this, right? We need to reverse this link over here, right? So if we are considering any node, what we guys are having at the moment, for that particular node, we are having a previous node, we are having a current node. This is previous, this is current, and this is the next node, right? And what do we want? That the next node should be pointing to the current node, right? So that's the basically logic to do this optimally using 3 pointers. So we would be doing nothing, but it would be just like that. Let's say we are having 3 nodes, 1 pointing to 2 and 3. So initially we would be having previous here and current, previous as null, right? It is nothing, it is a dummy node. This would be the current node, right? So what we would be doing, we will first store the next, and this would be the next, right? So what we will be doing, we will be storing the next node in a variable, and then we would be pointing the current node to previous. After that, we will move previous to the current and current to next. Similarly, over here, we will again point it to the previous node and again continue in the same manner. The time complexity for this approach would be big O of n. If you are still having any doubts, it would be cleared in the coding section. So again, for handling the edge cases, we will first write that condition only if head is null or head.next is null, then we can simply return head. Else, we will be taking 3 pointers over here: previous, current, which would be head initially, and next, which would be again null. Now our loop will be like this while current is not equal to null. As you can see over here, until we surpass this, right? So until this current node is coming to an end, till then we have to continue with our iteration. So what was our first step? That we need to store the next node in a variable. So we will just store it in next, that next equal to current.next, right? What was the next step? We will make current.next as previous. So current.next would be previous. Now what was the next step? Previous will be moved here and current will be moved here to next. So previous would be current and current would be next, and this will be continued. Now as we continue, the at the end point, current will be equal to null and previous would be just the last node before current. So that would be our new head. That's why we will say that head equal to previous, and after updating head we can simply return head. Or else we can also return previous directly, because that would be our new head. So let's try to submit this as well. So it is again accepted, and as you can see, it has a lower runtime from the past solution. So yeah, that's much for the today's session. I hope you enjoyed it. Make sure to like, subscribe, and have a great day ahead. Thanks for joining.